resistance is different from resistivity. Ang resistivity is electric field divided by current density, while ang resistance is voltage divided by current. Sa resistivity, ang units kay ohm meter, while sa resistance, ang units nato diri is simply ohms. If ato na sang i-rearrange ang variables, we get the Ohm's law expressed as voltage equals current times resistance. In terms of the length of the conducting wire and its cross-sectional area, resistance can also be expressed as rho times L over A. Whereas ang ato ang rho, mo na siya ang ato ang resistivity. L is our length of the conducting wire and A is the cross-sectional area. Resistance varies also with temperature. Kung increase ang ato ang temperature, mo increase pod ang resistance. Kung mas mabugnaw, mas gamay ato ang resistance. So RO there is the resistance at a reference temperature, usually 20 degrees Celsius. Ang alpha is temperature coefficient of resistance. Pareho lang na siya sa alpha sa resistivity per degree Celsius yapon ang unit. Ang T is your given temperature and TO is your reference temperature. Usually 20 degrees Celsius na siya. So for alpha here, we will use the same table 25.2 sa calculations. So for example, an 18 gauge copper wire has a cross-sectional area of 8.20 times 10 to the minus 7 square meters. It carries a current of 1.67 amperes. Find A, the electric field magnitude in the wire, B, the potential difference voltage between the 2 points in the wire 50 meters apart, and C, the resistance of a 50 meters length of this wire. So atong kuhaon una is electric field. We know sa ato ang formulas ganina, resistivity is equal to electric field divided by current density J. I-rearrange na to ang variables. Electric field becomes rho times J. So input na to ang values, pero wala pa manggod tayo values diha. Wala pa tayo current density. So we know that current density is current divided by area sa itong previous lessons. And ilisan nimo ang J sa electric field. So the electric field becomes rho times I over A. Then, na naman tayo values ani, rho is 1.72 given. Dili siya given. Constant. Resistivity is constant na nasa table ang 1.72 times 10 to the minus 8 ohm meter. Pangita ang resistivity sa copper. Times the current given, 1.67 amperes, divided by the cross-sectional area given po diha sa problem, 8.20 times 10 to the minus 7 square meters. You calculate, you get 0.0350 volts per meter. Muna siya ang unit sa electric field, or it could also be newtons per coulomb. Okay? So electric field has units in terms of volts per meter or newtons per coulomb. Next, the potential difference or voltage between 2 points in the wire 50 meters apart. So, ang atong formula for this, voltage equals electric field times the length. Naano siya sa previous lessons, wala lang nato makover. Naano siya ato ang textbook. So you substitute E na kay 0.0350 volts per meter times length nga 50 meters. So na kay 1.75 volts. Next, resistance of a 50 meters length of this wire. Resistance is equal to rho times L over A in terms of length and area. Na naman tayo value ani tanan. Resistivity na ani makuha sa table 25.1, 1.72 times 10 to the minus 8 ohm meter for copper wire, times length sa problem, 50 meters, divided by area sa problem, 8.20 times 10 to the minus 7 square meters, you get 1.05 ohms. Pwede po na ito gamitin ng Ohm's law to get the resistance. Although sa itong textbook, Ohm's law is expressed as V equals IR. Pag mo na siyang i-rearrange ng variables, Ohm's law po na siya. So you have the voltage 1.75 volts divided by current 1.67, you will get 1.05 ohms. So mas gamay ang imuhang calculations. Example 2. Suppose the resistance of a copper wire is 1.05 ohms ni siya at 20 degrees Celsius. Find the resistance at 0 degrees Celsius and 100 degrees Celsius. Solution na to, formula na ataani, R of T equals RO times 1 plus alpha T minus TO. So the first, for temperature of 0 degrees Celsius, our given resistance, 1.05 ohms times 1 plus temperature coefficient sa copper is 0.00393 per degree Celsius times given temperature of 0 minus standard temperature or reference temperature nga 20 degrees Celsius. You calculate it, you get 0.97 ohms. For the temperature of 100 degrees Celsius, the same ay mohang buhaton, you just replace 0 by 100 degrees Celsius, you will get 1.38 ohms.